We hear a lot about celebrity engineers and tech rock stars. But what about the people who built the very backbone of our modern world? In this explainer, we're going to peel back the layers on the single most powerful and maybe most overlooked force shaping everything we do: telecommunications. So let's just start with a big question. What is this invisible force that underpins literally everything, from the global economy all the way down to a simple text you send to a friend? Well, it's a network, a massive, unbelievably complex web built from light, from logic, and from sheer human ingenuity. It's the thing that connects us, empowers us, and quietly runs pretty much everything. To really get our heads around this thing, we've got to start at the very beginning, at its foundation. Because this network wasn't built by some algorithm or a big corporation. It was built by individual pioneers, brilliant minds whose scientific insights made all of this possible. I mean, that's the key thing to remember. This whole global system, it didn't just appear out of thin air. It was built piece by visionaries who could imagine a connected future way before the rest of us could even see. People like Dr. Shirley Ann Jackson. As a theoretical physicist at the legendary Bell Labs, her deep research into how light and electrons behave helps pave the way for the fiber optic cables we all rely on today. The ones carrying internet traffic at the speed of light. It's just a perfect example of how really abstract science can become world-changing technology. And her words here, they just perfectly capture the mindset you need to have. Dr. Jackson said, "Dare to imagine the unimaginable." And it's exactly that kind of daring vision that turns a scientific curiosity into the foundation of our entire digital world. Okay, so if the pioneers gave us the vision, what gives the network its engine? What's the actual stuff that makes it work? Well, behind every great technology, there are these fundamental scientific discoveries. And in this case, it actually involves a surprisingly obscure element from the periodic table. I want you to meet erbium. It's a rare earth metal, discovered way, way back in 1843. And for more than a century, it was basically just a chemical curiosity. But today it is the absolute heart of long-distance communication, all because it has this unique ability to amplify light. So how does this magic trick work? It happens inside something called an erbium-doped fiber amplifier, or an EDFA. So to put it simply, you've got this special fiber optic cable with erbium atoms mixed into the glass. A laser pumps energy into those erbium ions, getting them all excited. Then, when the weak light signal carrying your data comes through, those excited ions give it a massive power boost. It's like a series of tiny, perfectly timed rocket boosters for light, letting that signal travel up to 90 kilometers further with almost no loss of quality. And all that technology brings us right here, to today, to a world that is more connected than ever before, which means it has immense economic power. And also some really stark, double-edged realities. And let's talk about the money for a second, because the economic engine here is just staggering. The biggest telecom companies are pulling in hundreds of billions of dollars in revenue every single year. This isn't just a utility anymore, it's a massive, central pillar of the entire global economy. The investment really reflects that. Get this. The U.S. alone spends over $700 billion a year on research and development. A huge slice of that pie goes right into keeping us on the cutting edge of technology. Technology that is driven by the very connectivity we're talking about. But this incredible power, it has a dark side. Connectivity can be a tool, a weapon, and not having it can be a disaster. Let's look at a stark comparison. In the conflict in Ukraine, widespread access to the internet let citizens document what was happening in real time and rally global support. But in Sudan's civil war, frequent government-imposed internet blackouts meant that horrible things were happening in total silence, with the world finding out way too late. It's a really sobering reminder that access to this network can literally be the difference between life and death, between being seen and being invisible. And that disparity isn't just something that happens between countries. Even inside wealthy nations, we're seeing this digital divide that's creating what one source called the family from the other side of the tracks. It feels like we're at risk of repeating the exact same mistakes of the past, Back when highways and railroads physically divided communities by wealth and by race. Now, We're doing it again, but with data. So, where do we go from here? Well, the next giant leap forward isn't just about making things faster. It's about changing the fundamental rules of information itself. And that is leading us to some truly mind-bending new technologies. So, the huge shift is from the classical bit to the qubit. A classical bit, the foundation of all our computers today, is simple. It's either a 0 or a 1. That's it. But a qubit, because of this bizarre quantum property called superposition, can be a 0, a 1, or both at the same time. And that simple difference unlocks an exponential leap in computing power. And that kind of power, it unlocks some absolutely incredible possibilities. We are talking about things like totally unhackable communication that uses quantum entanglement, the potential to send data straight through the planet using these things called ghost particle neutrinos, and even manufacturing perfectly flawless fiber optic cables in the zero-gravity environment of space. It's wild stuff. Now, all of this might sound like science fiction, but it is quickly becoming reality. And that leads us to the final and honestly the most important point of all. This is a future that we get to create. You see, what happens next isn't set in stone. It's going to be the result of the choices we make. Technology just amplifies human intention, for good or for bad. So the real question we have to ask ourselves is this: what if we chose to build a future where connection is treated as a basic human right, not just a privilege for those who can afford it? The potential is there. The tools are being built right now as we speak. The choice of how we use them, that's on us. Let's connect not just our devices, but our destinies.